Hi everyone, so today we're going through 6B Division of Polynomials. Now for those of you that have done long division at some point during primary school will definitely remember this process. For those that haven't, get your pen out and your book out and get ready to take some notes. Okay, so first let's get used to our terms that we're going to be using. So we're going to be using the term quotient. Now, the term quotient will refer to your final product and then your remainder. Now, the remainder, I'm hoping you remember from when you first learnt division, and this is what's left over when we divide. Now, the thing we're dividing by is called the divisor. So I'm going to put it in terms of numbers without the polynomials first, just so when I use the terms, you're fully aware of how I'm using them. So say I wanted to divide 13 by 4. 4 is going to be my divisor because that's what I'm divising by. Now, when I get my answer, 4 goes into 13 perfectly 3 times. So 3 times is going to be my quotient. And then I'm also going to have a remainder of 1. Because obviously 3 goes into 4, 3 times 4 is 12, and then I've got that extra 1 to make up my 13. So 1 is going to be my remainder. Now, when we divide polynomials, it actually works exactly the same way, except we've got x to the power of 3 this time. So let's look at our first example. So I need to divide x cubed plus x squared minus 14x minus 24 by x plus 2. And I'm going to set this up exactly like you would with a shorthand division. So the number that you're dividing by is going to go out the front of that little thing that we set up. And then inside of this square thing, I'm going to put my x cubed plus x squared minus 14x minus 24. Okay, so let's start dividing. Now, first what I'm going to do is divide this x into this first term. So x cubed divided by x is going to leave me with an x squared. Now, what am I going to do from here? So first of all, I'm going to multiply these two numbers back together. So x squared times x is going to be x cubed. Now you'll notice these are exactly the same, and that's exactly what we want. We need these two to cancel out. If they don't cancel out, then you've divided them wrong and you need to go back. So I've got x cubed that I've brought down here. Now my next step is to also multiply the 2 and the x squared as well. So 2 times x squared is going to be 2x squared. And yes, positives and negatives do make a difference. I've got positive 2 here, so that's why I've written a plus 2x squared. Now you'll notice that I've stacked these two like this. They have the same power, and that's exactly what we want. Okay, next step. Now what I'm going to do is subtract the terms that I've stacked on top of one another. So x cubed minus x cubed is going to be 0, and again it should always be 0 here, so that's what we want. Next I'm doing my x squared up the top here minus 2x squared, so I'm going to be left with negative x squared. So remember, you can only add and subtract like terms, which is why it's important that these both have an x squared with them. Okay, now we start the process again. So I'm going to divide this by x. So I'm going to put it up here. So x squared divided by x, I'm going to put a minus x up here. Now the reason I've got a minus is because this is now a negative, and that's important too. So I've got negative x squared divided by x is going to leave me with negative x. Okay, again, I'm going to start multiplying back out. So multiplying my negative x with x is going to leave me with negative x squared. And again, these must be the same. So if you had written a positive here, you would have gotten positive x squared. And when you went to minus them, you would have noticed they wouldn't cancel out. And that's how you're going to check yourself as you're going through the process. So negative x times x gives me negative x squared. Great, they're the same thing. We're moving on to the next number. Negative x now times 2 is going to be minus 2x. x, and it's just 2x because this 2 doesn't have an x and I've just got 1x here, so minus 2x. And again, you'll notice these two have just 1x, and that's exactly what we want because we want to end up with like terms. Okay, now we're getting to the subtracting process all over again. Now, to make this process easier, you don't have to do this, but you can bring the numbers down if you would like. I know some people like to do that and rewrite them over and over again. Completely up to you. If you just like to, if you can just imagine it up here, that's fine. Leave it there or bring it down. Up to you. Okay, so again, we're subtracting our two numbers. So negative x squared minus negative x squared is going to be 0. And again, you're watching your negative. So this negative and negative becomes a positive, which is how I get these two cancelling out. Negative x squared plus x squared is going to cancel out to 0, which is great. Then I'm ending up here. So my negative 14x minus negative 2x. Again, I'm going to get a plus happening here. So negative 14x plus 2x, I'm going to end up with negative 12x. Okay, now I can bring the number down. Again, you don't have to do this step. You can just imagine it if you want to. Okay, starting the process again. 12x divided by x, I'm going to have just negative 12 because the x's are going to cancel out. So I'm going to end up with minus 12. And again, I'm multiplying them. So negative 12 times x is going to be negative 12x. Good, they're the same. Then negative 12 plus times positive 2 is going to be negative 24. Now, you can see here that something really convenient has happened, that everything's actually going to cancel out. So negative 12x minus 12x, that's going to be 0 because remember these two turn to a plus. Negative 24 plus 24 is also going to be 0. So I'm going to end up with 0. Now, when this situation happens, it means I have no remainder. It means that x plus 2 has perfectly been divided into my polynomial. So what does all this process mean now? This means that I've partially factorized this expression. So x cubed plus x squared minus 14x minus 24. I can now write that as x plus 2 and x squared minus x minus 12. And I'm getting this from what's at the top of my divided shorthand division thing. Okay, so now that I've got this, x plus 2, now with this quadratic that is in here, it doesn't stop here necessarily. Now, you're not always going to be able to factorize this quadratic. We know that from when we did quadratics. Not every quadratic can be factorized, but some of them can. So have a think for 10 seconds. Can we factorize this quadratic? Great. Hopefully you all recognize that we can factorize this. So our numbers here are going to be negative 4 and positive 3. So I'm going to factorize that into x minus 4 and x plus 3. So that is my fully factorized polynomial. So the x plus 2 comes from the number we divided by, and then we get left with this quadratic that we can further factorize sometimes. Okay, let's try that again with this expression here. So same setup as last time, x minus 2 on the outside, shorthand division symbol. Okay, now on the inside this time, you'll notice that x squared is missing. Now, we can't actually write it without the x squared. We do need it there. So when I'm writing this expression, I'm going to write my 3x cubed, but what I'm going to insert here is plus 0x squared. So with that 0x squared, technically 0 is the coefficient of x squared because I don't have one as part of my expression because 0 times x squared would just be 0 and that's why we don't write it. But it is technically still there. It just has a coefficient of 0 and I do need to include it because it's important as part of my process. Then I can continue writing the rest. So plus x minus 3. Okay, let's start the process again. So 3x cubed divided by x is going to be 3x squared. So 3x squared times x is going to be 3x cubed. And again, you want them to cancel out. 3x squared times negative 2 is going to be minus 6x squared. Okay, now you'll see here the reason that we write the x squared is because I need a like term to match it with when I'm going through my subtraction process. So 3x cubed minus 3x cubed, that's going to cancel out to 0. Perfect. 0x squared minus negative 6x squared, these two negatives are going to turn to a positive, so I'm going to end up with 6x squared. And again, you can bring down the x and minus 3 if you want to. Okay, 6x squared divided by x is going to be plus 6x. Multiplying that back out, so 6x times x is going to be 6x squared. And then 6x times negative 2 is going to be minus 12x. Okay, next, subtracting. 6x squared minus 6x squared is going to cancel out to 0. And then x minus negative 12x, so x plus 12x is going to be positive 13x. Again, we're going to bring down that minus 3. Okay, 13x divided by x, I'm going to write up here plus 13. And then 13 times x is going to be 13x. 13 times negative 2 is going to be negative 26. Okay, so 13x minus 13x is going to cancel out to 0. 3 plus 26 is going to be plus 29. Now this 29 this time, this is actually our remainder. So this time we do have a remainder, so sometimes they don't go perfectly into each other, and that is okay. So how we write this now is we have 3x cubed plus x minus 3. That was our initial expression. This can be factorized into x minus 2 and then 3x squared plus 6x plus 13. So that comes from the top here. And then your remainder, you're going to write at the end. So this is the remainder. So plus 29. Okay. So lastly, we have this example here. Now, the difference in this example is that we have an x squared minus 1. So we're dividing by a power higher than x to the power of 1. But the principle is the same. So when we do these, same as when in our last example the x squared was missing, we're also going to write 0x here, minus 1. So the expression is x squared minus 1, and we have x squared plus 0x minus 1, so we need to insert that as well. Then I'm going to put my expression here, so 3x squared minus 2x squared plus 3x minus 4. And then we begin dividing as per normal, except this time we're going to start with an x squared instead of just an x. So 3x cubed divided by x squared, I'm going to be left with 3x. So remember, when you're dividing powers, you're subtracting the power, dividing terms with powers, you're subtracting the powers. So 3 minus 2 just leaves me with 1x. Then I'm going to multiply back out. So 3x times x squared is 3x cubed. 3x times 0x is also going to leave me with 0x. So plus 0x squared. Now for this one, I'm writing x squared, even though it's still 0, because I've got this x times x, and I want it to nicely match up with my x squared term. That was the point of inserting this. And then 3x times negative 1 is going to be negative 3x. Okay, let's subtract. So 3x cubed minus 3x squared is going to be 0. Negative 2x squared minus 0 is still going to stay as negative 2x squared. Then 3x plus another 3x is plus 6x. And then I'm going to bring that 4 down at minus 4. Okay, starting the process again. So x squared, negative 2x squared divided by x squared is going to be negative 2. Then multiplying back out, I've got negative 2 times x squared, which is going to be negative 2x squared. Then negative 2 times 0x is going to be negative 0x. And again, don't forget about the x. We still want to keep it there. Then negative 2 times negative 1 is going to be positive 2 now. Okay, subtracting again. So this 2x squared is going to cancel out. 6x plus 0x is going to stay as 6x. And then negative 4 minus 2 is going to be negative 6. Now you'll notice when we get to this step, if I was to follow the process again and start dividing, I don't have enough x's here to divide by x squared. I have more x's that I'm dividing by than my initial number. So here is actually where I'm going to stop. Now the way I'm going to write my answer is my initial expression is 3x cubed minus 2x squared plus 3x minus 4. And then I'm going to factorize that as x squared minus 1. And then in another bracket, 3x minus 2. And then this is the remainder here. So I'm going to have plus 6x minus 6 on the end. So we're always adding our remainder to the end. Okay, now one last thing I want to leave you with is how to do this on the CAS calculator. So coming over to our CAS calculator here, let me just clear all of this. So now normally when you're dividing, you would just bring up a division symbol and type in what your answer is. I'll go back to this one here. So x cubed plus x squared minus 14x minus 24. And we're dividing that by x plus 2. Now, if you hit enter, it will divide it for you, but not in all circumstances. If there is some kind of remainder, it won't divide it for you. So this will only work if it works perfectly. So what you're going to use is we're going into algebra now, and instead of factorizing, because again it won't factorize it either, you're actually going to go into polynomial tools, which I'm hoping you remember because we're in the chapter of polynomials, and we're going to head into quotient of a polynomial. So this will give you, once you've divided, what this polynomial quotient is going to give you is what this expression is that ends up at the top. So I'm going to start with this one here because we did have a remainder with this one. So I'm going to start with my 3x cubed plus x minus 3. Now, you're not going to hit divide. What you're going to do is comma what your divisor is. So the divisor for this one is x minus 2. So I'm going to do comma and then my divisor expression, which is x minus 2. Now, if you press enter, it will give you the quotient. So we had 3x squared plus 6x plus 13 up here. So it gives you the quotient. Now, it doesn't give you the remainder, so you will need to work out the remainder separately. So to work out this remainder, we would need to go back into our polynomial tools, so menu, algebra, polynomial tools, and then instead of quotient, now you're going to click on remainder of a polynomial, and you're going to type in the same thing. So you're going to type in your polynomial, then comma, your divisor, press enter, and now it will come up with your remainder.